how do you write code with less bugs and errors? How do you make your code more readable and easier to maintain? Well, one crucial part of the answer is choosing good variable names. To be clear, variable names don't make your code faster or change any results. Your code will be as readable by your computer no matter what variable names you choose. But we don't write code to be readable only by computers. We write code to be readable by humans and computers. Let's compare the readability of some code examples where all examples are designed to do exactly the same calculation. I will use MATLAB syntax here, where parentheses are used when referring to a place inside a vector and where the semicolon at the end of the row suppresses echoing of the output to the screen. Our first example is b equals parenthesis x divided by 2 times a plus b end parenthesis times x plus c semicolon. Can you say for certain that you understand what this code is supposed to do? Perhaps, perhaps not. Let's modify it a bit. b equals parenthesis a1 divided by 2 times a2 plus a3 end parenthesis times a2 plus a4 semicolon. We can modify this a bit. Instead of having a1, a2, etc. as our variable names, we can use a vector where we have our values in position 1, 2, etc. The code would then look like this. I find all three examples shown so far rather difficult to read. Now let's instead use variable names that spell out exactly what each variable represents. We get distance traveled equals acceleration divided by 2 times time traveled plus initial velocity end parenthesis times time traveled plus initial distance traveled semicolon. Now it should be really clear to all readers what the code is supposed to do. But is this the best we could do? I have two objections against this code. My first objection is that the variable names are so long that I can't at a glance check that the code is correct. My second objection is something that has actually hidden an error in this code. Can you find the error? If I tell you that my objection is that this programming style is inconsistent in its use of small and large letters, do you find the error now? The variable time traveled with a small t in traveled is, in most programming languages, not the same variable as time traveled with a large t in traveled. A more consistent use of large characters, and thus a less error-prone programming style, could be to only use large letters when starting a new word. Within subdisciplines of physics, chemistry, and engineering, there is often a convention of what symbols to use for what. If I make a bad choice of variable names and write g equals x times f to the power of 2, or even make an extremely bad choice of variable names and write c equals e times m to the power of 2, most people would not immediately guess what I was trying to calculate. However, if I change my variable names in line with the commonly accepted convention and write e equals mc squared, my guess is that even a majority of the general public would understand. Let's try this with our equation above. We get s equals parenthesis a divided by 2 times t plus v0 end parenthesis times t plus s0 semicolon. Rather easy to read, don't you think? However, rewriting the code to s equals s0 plus v0 times t plus a times t squared divided by 2 is, at least in my mind, even more easy to read. So I hope you now see why the choice of variable names are so important for making your code readable. Finally, a comment on computational speeds. Although variable names have no effect on computational speed, putting your data inside vectors or not might. Even the order in which you write your calculations might influence the computational speed. However, understanding how you can tweak your code to increase computational speed requires pretty advanced understanding of computer memory management and how the optimization routines built into the compiler or language interpreters works. Furthermore, if computational speed is not of utmost importance, it is often wise to choose code readability over computational speed, since A, an easily readable code is much easier to find bugs and errors in by simply reading through the code, and B, a slow, correct calculation is typically better than a fast, incorrect calculation.